5th grade, chapter 4, lesson 4. Multiply using expanded form. The length of a day is the amount of time it takes a planet to make a complete rotation on its axis. On Jupiter, there are 9 8/10 Earth hours in a day. How many Earth hours are there in 46 days on Jupiter? You can use a model and partial products to solve the problem. So yesterday what you guys did was you simply multiplied the problem out and then came up with your answer by moving the decimal over, right? Okay. But yesterday you had maybe two or three digit number by a 1-digit number, and today you have at least 2 2-digit numbers in each spot. So they're going to show you a different way how to find that. So rewrite the factors in expanded form and label the model. So 46, we could write that as what, guys? 40 and 6. So 40 plus 6. And then 9 and 8/10, we could also write that as what? 9 plus, not just 8. What do I have to? 0.8, so 8/10, right? Okay. And then they already went ahead and pulled those things apart. So they put a 40 here, a 6 here, a 9, and an 8/10 here. So what we're going to do is, it's like bringing your 2 fingers together, okay, where they meet. So 40 times 9 is what? 360. What is 40 times 8? 320, but we had a decimal there, so we would move the decimal over once to the left like you learned yesterday, and you'd actually only have what? 32. Then we'd have 9 and 6 come together in this box, so 9 times 6 is what?
54.
54. And then in this box, we'd have 8/10 and 6 come together, and what is 6 times 8?
48.
48. But once again, we have how many decimal places? 1. So you have to move the decimal place 1 to the left, so our answer would be 4 and 8/10. So they showed us the model here. Now we have to plug that model in over here to the actual problem. So if we were going to work this like we normally would, we would take 6 times 8, or, well, what they did was they did their place values instead. So we said 40 times 9 was what, guys? 360. We said 40 times 8/10 was 32. And then you have to make sure everything stays in line, right, guys? Okay. Then 6 times 9 we said was what? 54. And then we said 6 times 8/10 was what? 48, but 4 and 8/10. So then I'd have to put this right here and then put it a little bit out, right? Just so I have all my place values together. Now what would we do first, guys, when we add?
The ones.
Drop down the decimal, and then we bring the 8. 0 plus 2 plus 4 plus 4 is 10. So I put a 0. Carry my 1. 1 plus 6 is 7. 7 plus 3 is 10. Plus 5 is 15. Carry my 1. 1 plus 3 is 4. So there are 450 and 8 Earth hours in 46 days on Jupiter. What if you wanted to find the number of Earth hours in 125 days on Jupiter? How would your model change? So instead of having 2 rows, our model would have 3. Instead of having 2 rows, our model would have 3 rows and 125 would be broken into, what would we break 125 into, guys?
120 and 5.
120 and 5. Another way, use place value patterns. A day on the planet Mercury lasts 58 and 6/10 Earth days. How many Earth days are there in 14 days on Mercury? So basically, they did what we did yesterday, only we have more than one digit, right? They have at least 2 or more digits that they're multiplying. So basically, they took 586 times 14, and then they got 8,204, and then they went back in and added their decimal place. So you would still get an answer of 8,204, only this time you have to move the decimal place over how many spots, guys? 58 and 6/10. So you have to move it over 1/10, right? Because it's 1/10 of the product. So we have to move it over one time. So I'm going to draw my little loop with an arrow. So there are 820 and 4/10 Earth days in 14 days on Mercury. What if you rewrite the problem as 10 plus 4 times 58 and 6/10 and use the distributive property to solve? Explain how this is similar to your model using place value. So basically, that's doing what, guys? It's basically like using the partial products and then adding them together, right? This is basically like partial products and then adding them together. Okay, they want us to find the products of these two answers, but they, on the first one, want us to use a model. So we are going to draw our box and then divide it into 4 pieces. So what are we going to break 52 into, guys? 50 and 2, so I'm going to write 50, and I'm also going to write 2. What are we going to break 3/500ths into?
3 and
3 what, though? Can we just say 3?
3
3 tenths and 500. So, what is 50 times 3, guys? 150, but then we have to move the decimal over 1 place to the left. So our answer is 15. Then what is 3/10 times 2? That's 3 times 2. 6, but then we have to move our decimal over 1 place to the left. So our answer is 6/10. All right, 5 times 5 is, actually 50 times 5 is 250, but how many place values do we have, guys? 2. So what would our answer be if we move the decimal over 2 places? 2 and 50 hundredths or 2 and 5 tenths? What is 5 times 2? 10. How many place values do we have, though?
So 1 place.
We have 2, so it would be
1/10.
it'd be 1/10 or 10 hundredths, right? You could write it either way. So now what do we do once we have all of those things together, guys? Add them. So I have 15, and then my decimal, right? Then I have 6/10. So I have to keep all my decimals in line, right, guys? Then I have 2 and 5/10. So I write 2.5, keeping my decimals in line. And then I have 1/10. So I write 0.1 to keep everything in line. What's the first thing I do?
Bring down the decimal.
Bring down my decimal. 6 plus 5 plus 1 is 12. So I put a 2, carry my 1. 1 plus 5 plus 2 is 8. And then I bring down my, so my answer is
18 and 2/10.
18 and 2/10. Now they want us to use place value. So I'm going to put my 3-digit number on the top. Even though it's smaller, I'm still putting that on top. So I'm going to put 9 and 18 hundredths times 16. And right now, are we pretending like there is not a decimal there yet? Right. We're pretending like there's no decimal there. We will deal with that when we get our answer. Right? So I would cover up my 1 and I would say 6 times 8 is 48. So I put an 8. So I put an 8 and I carry my 4. 6 times 1 is
6.
6 plus 4 is, so I put a 0, carry my 1. 6 times 9 is
54.
54 plus 1 is
55.
55. Then I cross off my little 1, I cross off my little 4, I cross off my 6, and I put a 0 because we're now moving to the tens place. 1 times 8 is 8. 8 times, or 1 times 1 is
1.
1 times 9 is,
9.
then I do what, guys?
Bring down the decimal.
Then I add. 8 plus 0 is,
8.
0 plus 8 is,
8.
5 plus 1 is 6. 5 plus 9 is
14.
14. How many decimal places did I have in the original problem? 2. So I'm going to put my dot here and move it over twice and put my little arrow. So my answer is 146 and 88 hundredths. So draw a model to find the product. Basically, they took 19 times 75 hundredths and they broke 19 into 10 and 9, and they broke 75 hundredths into 7 tenths and 5 hundredths. So what would 7 times 10 be, guys?
70.
70, but how many decimals do we have?
1.
1, so you have to move it once to the left, so our answer would be
7.
7. What is 5 times 10? 50. How many place values do we have?
2.
Or with the decimal, you have 2. So if we move the decimal to the left twice, what would our answer be?
0. 5 tenths.
0.5 or 5 tenths. Then what's 9 times 7?
63.
63. How many decimal places do we have?
1.
1. So if we moved it one place to the left, we would have what?
6 and 3 tenths.
6 and 3 tenths, or 6.3. 9 times 5 is 45. How many decimal places? 2. So if we moved it 2 to the left, we would have 4,500. Now what do we do with all those guys? Add. So we would do 7 decimal plus 5 tenths, keeping all my decimals in line, right guys? Then 6 and 3 tenths, and then 4,500 hundredths. Now, since I actually go another spot past my other place values, what can I put out there to hold my spots?
0.
Zeros, because those still mean the same thing, right? What's the first thing I do? Bring down my decimal. 0 plus 0 plus 0 plus 5 is?
5.
5 plus 3 plus 4 is?
12.
12. Carry my 1. 1 plus 7 plus 6 is?
14.
14. So my answer is?
14 and 25 hundredths.